Hello, this video looks at interval notation, inequalities, and domains in math analysis. So what we're first going to look at is talk about how different symbols are included and not included within math. So what happens is, one example is in an equation, okay? So when we have an equation, we will have included values if there's an equal sign, or if there's a less than or equal to, or greater than or equal to. All those symbols mean that we are including the answer, the value, as part of the solution. In an equation, when we're not included, it would be not equal to. Or for the inequality version of it, it would be strictly less than or strictly greater than. Then we have things on a number line. On a number line, when you were in probably Algebra 1, you did some graphing inequalities on number lines. And so when you had a number line situation, if you had, let's say, x is greater than or equal to 3, you would have a location at 0 and then another number 3. And on a number line, you would have a closed circle and then the line to represent your answer. So being included means that you have that closed circle. Then if we had x is strictly greater than 3, we would still have the 0 and then the 3, and then we would have an open circle to show not included and then going in that direction. Now, when something is not included, that means everything that's really close to it counts, but not the actual number. So 3.000000001 is included in the solution, but 3 itself is not. Then we have graphing in a coordinate system. So what happens when we have a coordinate system? So with a coordinate system, what happens is that if you were to graph something with an x and y value, when you graph an inequality when you're not including it, you're going to end up with a with a solid line when you are including the answer. So this is solid. When it is not including the answer, you're going to end up with a dashed or dotted line. So a dashed or dotted line works for the coordinate system. Well, now what we're talking about is we are talking about interval notation. So with interval notation, I'm having some issues today. With interval notation, when we are including our values, that means we're going to have a bracket. When we are not including the values, we have parentheses. Now, one of the important things to know with interval notation is that if you ever have infinity or negative infinity, so if you ever have the infinity symbol, it will always have a parentheses because there is no such thing as infinity, so there's no endpoint to it. So now let's look at some examples. So what you're going to be seeing is, first off, if this is as an inequality. So right now, our first example is we're going to look at x if 3 is less than or equal to x is less than 7. So the first thing that I want to do is I want to draw this onto a number line. So here is 0, here's 3, and here's 7. Now, if you notice, I'm not necessarily putting every single value in there because we just need these as indicators for what we're doing. So at 3, we have less than or equal to, which means it's included. So that means at 3, we're going to be using a bracket or a closed circle for that value. Then at 7, it is strictly less than, which means we're going to use a parentheses or an open circle, and our area that we're talking about is in between. In the math book that you're using, they use this symbol for some of the graphs. But now if we're going to write this answer in interval notation, our domain is going to be listed instead of as an equality as bracket 3, 7, and then parentheses. That means we are including 3 as part of our answer, but 7 is not included as part of our answer. Now let's look at our second example. In the second example, we're going to make another number line. And this time it says x is greater than or equal to -3. So here is 0, here's -3. So because this is greater than or equal to, that means we're talking about a bracket or a closed circle. And greater than or equal to means it's going to the right. Now, since it's going to the right forever, that means we are going to infinity. So when we do this in interval notation, we always do this from left to right. So our lowest value is -3, and we are including -3 as part of the value. And our highest value is infinity, but we are going to put a parenthesis on that side because there is no infinity. Let's try one more example. Or actually, if you want to try and stop it, try the example and then check your answer. That works as well. But here we go. Our number line first. So our number line, we're going to have 0 and we have +4. So at +4, we have strictly less than. So that means open circle and we're going to the left, or it means parentheses and we're going to the left. So now what does that mean about our interval notation? So the first thing is we need to identify what is this number out here? What are we going to on the left side? Well, what happens in this case is since it's getting smaller and smaller and smaller, we are approaching negative infinity. So that is going to be our location on the left, and then we are going to +4. So +4 has a parentheses because of the open circle, and infinities also have parentheses. So that means our domain is parentheses, -infinity, 4, and then close the parentheses. We're now going to look at this with some graphs. So the first thing, if you notice, we're going to find our domain and our range. But on our first one, it is not a continuous graph, which means since it's not continuous, that means we have to lift our pen to put parts of the graph in there. So we cannot list this as standard interval notation. So that means in this case, we're going to write this in set notation. So what is set notation? That means our domain, we are just going to list every x value that has a point next to it. So that means our domain is -4, -2, 0, 2, and 4. That is the domain that is there. The range is going to be the y values. So again, we always go from the lowest to the highest, and we're going to list all of the y values that are there. Well, our range is -1, 0, 1, 2, and 3. Those are all the values. But since it is not a continuous graph, we cannot list that in interval notation in our typical sense. For the next example, we can list it in interval notation. So the domain is the x value. So what we're going to do is we're going to look at what is the smallest value of x. Well, the graph starts here at -2, and it seems to cross into that. So that means 2 is the smallest number. The biggest number is over here, which is 4. So our graph is going from 2 to 4. And we are including both of those values because we have it touching and then we have the closed circles. Now the range is going to look at from the lowest value to the highest value. So where's our lowest value? Well, the lowest value starts at -3 and the highest value goes to +2. And again, because there are closed circles at both of those locations, that means we are going to put the brackets because it's strictly included. Now, our last example that's posted here, we're going to look at domain and range again. So the domain seems to be starting at 0, and you see how there's an arrow on the side? That means it's going to continue going on forever. But what happens here? Well, this is an endpoint, which means we don't necessarily know if it's including or not including. Typically, when it's including that, they will identify a very significant point at the end. Because there is no significant point at the end there, then we are going to say that we are starting at 0 and we're going to infinity, but we're not going to include 0 because that single filled in circle is not there. Now, for range, we're going to look at what is the lowest point to the highest point. So the range, the lowest point is here, the highest point is here. So that means our lowest point is at -3 and our highest point is at +3. Now this graph is actually called a cyclical graph based on what's going on. So even though we have this arrow here, what ends up happening is the graph continues going on that up and down pattern. So that makes it that we are not going to go any higher or lower than the -3 to +3. So we have bracket, -3, comma 3, and then another bracket. Now, the last thing I want to show you in terms of domains with graphs is the following. It is possible to have different segments within our graph. So if we have a graph, and we're going to start here at the -3, -3, and I'm going to go up to this point right here and put an open circle. Then I am going to leave a space. I'm going to put an open circle here and then a closed circle there. So now let's look at our domain and our range. So the domain, we always read from left to right. So we know that we are going to be starting at -3 because that's our smallest x value, and there's a closed circle there, so that gets a bracket. But you see how there's a space in the middle of the graph? Because there's a space in the middle of the graph, that means we are going to actually have two different domain sets. So our domain is going to go from -3 to -1 because that's where that first piece ends, is at -1. But we had an open circle, so that gets a parentheses. We're then going to put a U, which stands for union. The union is the connection between the two domain areas. And then we go over to +1. Now at +1, though, we have an open circle, so that means it gets a parentheses. And it's going to +3. And at +3, we have a closed circle, so that gets a bracket. Our range. So now let's look at the range. When we examine the range, we have to start from the lowest value to the highest value. So if you notice with the range, we have a complete range. There is no space in the y direction between the points. The first line goes from -3 to 0, and the second line goes from 0 to 3, so everything is included. So our lowest value is -3, our highest value is +3, -3 has a closed circle for the y value, so it gets a bracket, and then +3 has an open circle, so it gets parentheses. So this is the first bit with domain and range in interval notation. It will get easier over time.